Sometimes you model something low or mid-poly and you want to add some details to it. But sculpting them and then using this model on its own, it's not the best idea. In this situation, you can use your high poly model to actually bake all the details on your low poly or mid poly model and then use it as a normal map. But what exactly are normals and normal maps? First, normal in this case doesn't mean expected or typical. Every vertex, edge, or face on your model has a normal, which is a direction that they are pointing at. Let's take a look at some normals in Blender. We select the cylinder and go into the edit mode, and then from Mesh Edit Mode Overlays, we select Display Vertex Normals. These blue lines are vertex normals, so they tell us which direction each of these vertices are pointing. Let's select the face normals too. And again, we see some lines. Vertex normals are oriented at a 45-degree angle, and it is the mean directional vector between the vertical axis of the top and the horizontal axis of the sides of the cylinder. Let's scale the bottom of the cylinder. We can see that the vertex normals are changing their direction, and it's because the side faces normals are no longer perpendicular to the top normal, so the mean normal for the vertices will change too. By manipulating these normals, we can achieve really interesting results. Remember that the size of the normals overlay depends on the object size. Let's turn off the overlays and add a geometry node by pressing Shift A, Input Geometry, and Mapping node from Vector, Mapping, and connect the normal from the geometry node to the vector of the mapping node, and the output to the normal input in the principled shader. We will switch to the rendering view. Material is glossy to see the reflections of the environment. Now we can manipulate the location and rotation of the reflection by changing some values in the mapping node. So, as you probably noticed, we haven't changed the geometry of the surface and we still can manipulate how the light reflects from our object. If we can change the reflections, maybe we can also change the look of the objects too. Yes, we can, and for demonstrating, we'll add a bevel node from Shift A, Input, and Bevel. Let's take a look at this cube. Its edges became blurred, so we need to change the radius of the bevel to something like 0.005, and now we have a nice bevel, but we didn't add a single vertex to our mesh. These were very simple examples of how to manipulate normals, but what when we want to add more details to the faces of our objects? We can use normal maps. Normal maps are specialized textures that modify these surface normals to create the illusion of detail without adding extra geometry. By altering the surface normals, normal maps can make a flat surface appear bumpy, grooved, or textured. By using normal maps, you can add rich detail to your 3D models without increasing the polygon count, making your scenes more visually detailed and realistic while maintaining performance efficiency. Let's select the object in our scene and add some surface details without adding the geometry. First, we will disconnect the bevel node by pressing Ctrl and clicking the right mouse button above the link, and we will add a noise texture by pressing Shift A, Texture, Noise Texture. We don't see any blue outputs in our noise texture, so we need to add a node that will translate the factor of the noise to height and then to the normal. We will select it from Shift A, Vector, Bump, and we see that Bump node has the normal output and height input, which has the same color as the factor of our noise texture, so let's connect them and then connect the bump node normal to the normal of the principled shader. And we see now that the surface of our objects looks very bumpy, and again we didn't add any geometry. It's technically not a normal map, but I had to mention it as it is another method of changing the way the surface reacts to light. This is how we can use the procedural texture to add some dimension to our models, but there is another way of doing that by using other type of the normal map, more custom. Let's take a look at it. We will paint this model later in the course, but let's add a normal map from the files of this lesson by pressing Ctrl-Shift-T while the principled shader is selected and choose the texture. Let's see how the normal map looks. We can plug it directly to the material input by pressing Ctrl-Shift and clicking on the texture. Normal maps are mostly blue because many surfaces face outward, and this direction is represented by a high blue value. The other colors are pointing in different directions. That's why we see that the surface after applying the normal map looks like it is not really perfectly flat. But let's see the material output again and change the base color to dark gray. All the details on the surface appeared and it looks totally different. But we can see that with the texture there is also another node called normal map. This is similar to the bump node we talked about earlier, so again we need to translate the color data from the normal map to the normal data that the principled shader will understand. Another important thing is that for normal map and other maps will connect to the principled shader, the color space must be set to non-color, and Node Wrangler does it automatically if the textures are named and exported properly, so I highly recommend using it. This way you won't forget about it and will waste time on searching for information why something doesn't look right. But it's just good to know if you'll ever add texture by hand. And why should it be changed to non-color? Because we don't want to perform any color space conversion to them. Now try to change the strength of the normal map and see what happens. Usually it's better to keep it at 1 and just make details more visible in the texturing program, but sometimes we can increase this value a little. The most important thing is to have a nice smooth surface without any artifacts. In the next lesson, we'll talk about adding some geometry to add more details, but